All right, the final factoring lesson, right? And this is kind of like two special cases, perfect square trinomials and difference of two squares. So let's take a look at this. If we square a binomial, right, we can write it out as 3x plus 4 times 3x plus 4. If we go ahead and FOIL this out, we would get 3x times 3x is 9x squared plus 12x plus 12x plus 16. And when we combine those middle terms, we get 9x squared plus 24x plus 16. Now, what this is when we square a binomial, there's a common theme that happens, right? And that common theme is if I take the square root of this, the square root of 9 is 3, square root of x squared is x, and I take the square root of 16, that would be 4. If I take 3x and 4, multiply it together, and double it, that would give me the middle term, right? So what happens is when we get a perfect square trinomial, right? If you take the square root, multiply and double and get the middle term, you know right away that that's going to be what it gives you right here. Okay, so let's take a look at what I mean by this. So if I wanted to factor the one below, we could use AC method, no doubt. We could use AC method. However, if I know I can take the square root of this evenly and get 2x, the square root of 4 is 2, square root of x squared is x. If I take the square root of this, I get 7. If I multiply these together, I get 14x, and if I double that, I get 28x. Does that give me the middle term? Yes. So what happens is, I know this is going to factor out to be 2x. Since this middle term is negative, I'm going to put minus. And then the square root of 49 is 7, all squared. And then notice here, if I wanted to check my answer, 2x minus 7, 2x minus 7, 4x squared, bam. Minus 14x, minus 14x, negative 28x. Negative 7 times negative 7, plus 49. That is what I get there. So you know this factors as 2x minus 7 all squared. The next one, square root of 25, x squared. Square root of 25 is 5. Square root of x squared is x. Now, square root of 4 is 2. If I multiply those together, I get 10x. If I double it, I get 20x. Is this a perfect square trinomial? Yes. So right away, this is going to factor as 5x. Take the sign of the middle term, plus 2 all squared. Does this happen often? Not really. But can it? Yes. So, next one. If I look here, if I multiply these out, 3x times 3x is 9x squared, plus 6x, minus 6x, minus 4. So, what happens to the middle terms here? They cancel. So I get 9x squared minus 4. Now here's the thing. I still could use AC method if I wanted to, right? If I wanted to use AC method, if I made this 9x squared plus 0x minus 4, I could use AC. But anytime I have two terms linked by subtraction, if I look here, two terms linked by subtraction, what I'm going to do is see if I have perfect squares. The square root of 9x squared is 3x. Square root of 4 is 2. Since those are two perfect squares linked by subtraction, what we're going to do is we're going to add those and subtract them. And what do you know? We get what we started with. So this here is called a difference of two squares. If I have a squared minus b squared, I know this is going to factor to a plus b times a minus b. So if I take a look at these examples here, two terms linked by subtraction, square root, square root. Let's see if it works out. Square root of 100 is 10. Square root of x squared is x. Square root of 1 is 1. Two perfect squares linked by subtraction, 10x plus 1, 10x minus 1. Next one, check for square roots. 6x, that's going to be 5. So right away, 6x plus 5, 6x minus 5. Now here, this one is not possible. And the reason is, yeah, I can take the square root of this, get 2x, square root of this, get 5, but because they're linked by addition, I cannot do it, right? And it's because they are linked by addition. It doesn't create a difference of two squares. So let's talk about completely factoring here. What do I always start with? I always start with the GCF. So if I start with the GCF here, 36 and 4 can both be divided by 4. So divide by 4 is going to give me 9 minus x squared. Right? So now I have to look, is 9 a perfect square? Right? So if I took 9 minus x squared, square root of 9 is 3, square root of x squared is x. Is that a difference of two squares? Difference meaning subtraction, perfect square. So bring down my GCF, and now this will be 3 plus x, 3 minus x. The next one, all of these can be divided by, so if the leading coefficient is negative, we're going to pull out a negative. 8, 24, and 18, the greatest common factor there is 2. If I divide everything by negative 2, I'm going to get 4x squared plus 12x plus 9. Now, I'm going to check and make sure this will work. If I took 4x squared plus 12x plus 9, I notice perfect square. Let's check. Square root of 4x squared is 2x. Square root of 9 is 3. Multiply them. 6x, double it. I get 12x. Does that match the middle term? Yes. So negative 2 times, right? We know the first one's going to be 2x. Since it's positive 3, it's going to be plus 3. 2x plus 3. Or we would look at it like negative 2 times 2x plus 3 all squared. And that's how that would factor. Go ahead, do the homework assignment, and let us know if you have any questions.